Welcome again. So today let's talk about Doppler effect, what it is, and also trying to solve some questions. So when we are talking about Doppler effect, it is the apparent change in frequency of a wave due to relative motion between the source and the observer. So what's there is a Doppler effect is just is all about changes in frequency. For example, if you see or you hear an ambulance coming, you are trying to hear the sound. So it's just a change in you are relating the sound, you as an observer and also an ambulance acting as a source of sound. So the key points you should take note in Doppler effect is actual source frequency. The frequency of the source is usually constant, it doesn't change, but the observed frequency changes. The frequency you observe, you find that if it's 10 meters away from you, the frequency will be different when it is just 5 meters away from you. So the observed frequency, it changes, and Doppler effect requires what? Relative motion. So as we said earlier, when a sound wave moves toward you, the sound becomes higher in pitch. When it moves away, the pitch becomes smaller, becomes lower. For major exam questions, the speed of sound is usually 345 meter per second. So, but if you have not been given, if in the question they gave you the speed, use that speed, but the speed you are going to be using of sound is 345 meter per second. And the main Doppler effect formula, formula we use in Doppler effect is this is the main formula we use in Doppler effect, where this FO means observed frequency, the FS means the source of the frequency of the source, and V is just the speed, which is 345 meter per second. VO means the observed speed, while VS will mean the speed of the what? Of the source. So these are the formula you are going to be using, but this positive or minus, the sign rules, it depends. Is the observer moving toward or away or the source? So that's what determines the sign of this formula. So we are going to do them, and we are going to do the cases which are usually there. So this is how we use the sign. So when the observer is moving toward the source, we are going to use positive V initial, in which formula, the same formula I wrote earlier. So we are going to, the formula is going to be wrote like this, is equal to Fs times V plus or minus V initial over V. So there's initial there. So observed speed. So when we are moving towards the source, when the observer is moving toward the source, there where there is positive, we are going to, it's going to be Fs V plus V, like this, because the observer is moving toward the source. But when he's moving away from the source, we are going to use this formula, but here it's going to be negative where there is a positive. So this is the case of the what? Of the observer. Now what about the case of the source, if the source is the one making movement? So when it's in terms of the source, we are going to use this formula. F is equal to, the observed frequency is equal to Fs. So on top there's just going to be V. So when it is in terms of source, on top is just V. It's the opposite. When it was the observer, on top, that's where there was plus or minus. But here it's going to be V minus or plus V S. So when the source is moving towards, the observer, instead of the, it's not source here, it's observer. observer. So when the source is moving toward the observer, it's going to be negative. Now you may be confused, why is it negative? It's negative because Fs V over V minus Vs. So because the source is moving toward the observer and we want to make the pitch should be higher. If we make positive here, which means the value which is down is going to be bigger than the value on top, which means making the pitch lower. But if we are saying V minus, which means the value which is down is going to be what? Is going to be small, making the pitch higher. So that's the difference when we are talking about the observer and the source. So these are the only two cases that you are going to be finding. There is another case we call it the general case, when both of them are moving. So this is the formula we use in the general case when both of them are moving. So again, the sign is going to depend on what? On is it moving towards or away. For example, if here the observer is moving towards, we are going to use positive here. We check again, is the source moving away or toward? So if it's moving towards, we are going to get the negative one. If it's away, we are going to get the positive one. So this is the general case when both are moving. If you are going to know these three cases, no question on Doppler effect can challenge you. You just need to know these three cases. The only thing you should just practice some questions so that it becomes part of you. So we are going to do some example. An example. So this is an example. We have an ambulance emits sound at 400 Hz and moves at 75 miles per hour. So you're going to find an ambulance, it's a source of sound, which is having that frequency and that speed. A car moves toward it at 55 miles per hour. Speed of sound is 345 meters per second. Find the frequency when the vehicles approach each other. When the vehicles are approaching each other, which formula are we going to use? They are all moving towards each other. So on top, V, for us to make it big, because they are moving toward each other, the pitch is going to be high, we put a positive observer over down. We are going to, for us to make it bigger again, because they are moving towards each other, we are going to put the what? The negative. So that's how we find the formula. We just analyze the situation. So when we just plug the value, we're going to get the answer, but we need to change the miles per hour into what? Into meter per second. So let's go ahead and change it. To change it, we just say, for example, that one is 75. That's the speed of the speed of the ambulance, which is the source, times 0.447. This is just a conversion for us to change it to miles meter per second. The answer we are going to get is 33.5 meter per second. We also change for the observer, which is 55 times 0.447. The answer we are going to get is 24.6 meter per second. From here, we just go to the formula and plug the values. At the end, you are going to find that the answer you are going to get is 475 meter per second. So we have just plugged the values in the previous formula. Plug the values here in this formula. Fs, we know that the frequency of the source is what? Is 400, and the V is 345, and the V initial we have calculated, so we have just plugged in the formula. We got the answer 475 meter per second. Now let's go to for B. For B, they are saying when the vehicles pass and move away from each other. So which formula are we going to use? So just know how to analyze. For for Doppler effect. So it's going to be Fs. For us to make the frequency small, on top it should be minus Vs. Because they are moving away, while down it should be what? Plus. So don't be confused. I explained why we are using plus instead of minus. We want to make the value small. So how do we make it? When the denominator is big, the value is going to be small. So at the end, we just plug the values, which is at the end we are going to find the value to be 339 Hz. So you can try them on your own, but this is the answer. So Doppler effect, from now on it shouldn't trouble you. Just go and try to do some questions. That's all about Doppler effect. You just analyze, is it moving towards or away? So if it's a general case where they are both moving, just look. If the observer is moving towards, you put a positive on top. If the source is moving towards also down, you put a negative, and the opposite is also true. So that's all we had. Next time we'll look on standing waves. So bye and thank you for watching. Just subscribe to the channel for more videos in physics and other courses.